what these companies have as the asset in this whole game of AI is data. And this is where I think this company should focus their resources. They want to have people who understand the data and the process and who are AI savvy.
Welcome to the Skellig Automation podcast. My name is Chris Demers, and today we got a special guest, somebody who I think probably has thought more deeply about using AI in regulated industries than perhaps anybody else I know. It's my friend Nikolai Makaranka. Nikolai, thanks for being on the show today.
Thanks, Chris. Appreciate that.
Do you want to start by maybe giving the audience a little talk through your background, where you've come from, what you're up to now?
Yeah. Nikolai Makaranka. I'm currently the founder and CEO of Daikon AI. We build AI solutions for quality management, helping companies in life sciences to improve, speed up, make more effective quality decisions, accelerate their quality processes. I spent pretty much my whole career in life sciences. So was at Philips for 9 years, then at BMS for 5 years. Worked always in manufacturing slash quality slash supply chain, or maybe operations is a better term, and work with AI ML solutions, data solutions, and this is sort of my area of interest, and definitely always been over this time looking for opportunities to apply AI ML in life sciences and specifically commercial operational space. It's definitely not easy. So looking forward to our discussion to dissect what could we do better and what potential solutions, which path should we take.
I think there's a lot of fluff, obviously, out there right now. I mean, everybody's talking about AI. And I see now that you're on kind of the software development side, coming from maybe more the end user side, how much of that AI is useful from a software engineering perspective? Like you see a lot of people who
Yeah,
are vibe coding different projects. I'm
yeah.
assuming you're not vibe coding Daikon.
It helps. I think the term vibe coding is maybe sort of a little bit too playful to communicate sort of the value, the seriousness of the shift in that.
Mm,
Uh, Overall, I think would be good to start to preface this with saying that software engineering, I think this is where the AI value is most evident, and it's an area where there's sort of a almost like perfect storm for applying AI. The reason I'm saying this because first you have GitHub, right, or other code bases that are available publicly. So you have tons and tons of data that you can use to train your model. Second, this data is in very formalized, structured, um, uh, created in very formalized, structured way. So it's very straightforward how to uh, sort of to explain to the model, right, what is right and what is wrong, and moreover, you can give it all kind of different tasks, and you can objectively say, okay, did it complete this task correctly or not? Because you can run sort of a function, right, and you can say, let's say the answer should be true or false, and you can see what the model got. Um, Plus it's all done digitally, so there are no studies like in pharma, right? There's no much uh, stuff happening, let's say, in the lab that you cannot really observe. It's all done in a computer. So in that sense, it's a little bit ironic that sort of, everyone thought AI would go after these low skilled jobs, but in reality
it went straight for the.
appeared, yeah, it was straight for the creator. It's like almost like a Frankenstein. Yeah. And so it's interesting to look at this industry, and we hear as well a lot of very big proclamations around things like, okay, AI is writing like half of the code in our company, and yeah, I hear a lot of things like that. I found one very credible source on this. There was a lab in Stanford that actually their whole specialization just to track impact of AI on software engineering field. And one thing that they do differently, they don't use surveys, or they don't just go collect qualitative data. And they don't look simply at the commits in GitHub. They actually build a model to assess the quality of these commits, the complexity, and to grade them as if human graded them. So it's really very thorough assessment of the work done, and that helps them really assess, how much AI helps, because you definitely get more commits probably with AI because you just like do things faster. But you also would rework things, sometimes would veer off the course, so you need to uh, fix something. So the number of commits grows. So you cannot really just rely on that. You need to see, okay, is it like a commit to rework, or is it a commit that just
Is actually
you
productive.
submitted and it's done?
Yeah.
So they've done this analysis. What they found is that the net um, gain roughly 15-20% in productivity. And it's actually interesting how this number comes out as a net gain, is that you get a gross gain of 30-40%, but there is a negative gain that slows you down of 15-20% of rework. So basically, they produce way more with AI, but you have to rework stuff afterwards, and that kind of offsets some of these gains. And so that's how you basically end up with this 15-20%. And this is what I think is the many of these proclamations, like, okay, half of the code is in our company is written by AI. They sort of come from here. It's really developers using AI, then they're using their own time to fix some bugs AI introduces, but net gain is 15-20%.
Mm-hmm. So that actually got me thinking about something that I think we saw a lot of over the last 5 years, which was like the companies, the AI or machine learning companies that kind of rose out of, well, we'll take your paper batch records and will give us the scans of them and we'll run it through algorithms and, you know, maybe we'll get you most of the way there. But I feel like the problem is it's most of the way there, right? Like mistakes will be made, but you have no idea where those mistakes are made. And
Yeah.
so like you at the end of the day, like you have a human still sitting in the middle who's like manually checking these paper batch records against these models. So like
Mm-hmm.
what is maybe the net efficiency gain is more realistically like you say 10-15%,
Yeah.
not some crazy value.
And I think it's important as well to separate this traditional ML,
Mm.
which is, I'm not even sure, you would call it AI, given the current connotations that you get with this term, right? Which is primarily Gen AI, right?
Yeah,
And
yeah.
this is something that like fully autonomous. But tons of this algorithmic use cases where it's all around, let's say, some optimization algorithm, right? How do you do product development making fewer experiments, or how do you optimize your yield given these parameters like PAT and things like that? So these are legitimately AI kind of use cases, but they're definitely completely different category. And I would say this use case better explored, and they've proven to work, and there are definitely great benefits as well. You can get like percentage points of yield. This is like an enormous amount of savings for companies. Uh, the challenge of implementing those, I think, a little bit different, and these are more challenges around implementing any software system in a regulated environment. And the challenge is that, so first it's just tough to build software, to implement software for a company whose primary operations have nothing to do with the software, right?
Right.
We're not digital natives like Google's and
Mm-hmm.
the world and things like that. Plus, maybe stemming from them is the fact that we just like so behind. And when I say we, I say the life sciences
Mm-hmm.
industries. We're so behind in techniques, in processes, even in thinking, how you build software, how you implement the processes that we primarily have around computer systems validation. They are built for stuff that, some I don't know, 90s maybe, where you develop the software and then it's going to stay with you for 10 years. And to be honest, this is what happens, right? If you spend just, it's like so prohibitively expensive to validate something that you really need to have a very compelling business case. And the hurdle for this business case is like becomes so high because there's fixed cost, right? Time, effort, and it's primarily now focused on these very large systems that you would implement, and you're just going to live with this no matter how painful it is for the next 10 years. So that's a part of the problem. And the expectation was that, oh, when ChatGPT, the original one, came out, everyone thought that's a completely new thing. It's new way of doing things, right? Now you don't have to develop anything. You just like throw your data into this chatbot and you get answers about whatever problem you have in mind. And the reality appeared after how many, like 3-4 years after that, 3 years probably, is that actually developing AI solutions is more complex than just traditional software. It's traditional software plus more complexity, more sophistication around testing and evaluations of the solutions. So that's why I don't think that things became easier, things became worse. And the focus should be really not on the AI itself, but on the processes of companies, how they validate. If someone internally wants to develop something, I think this is where they need to look at how do you create a sensible, automated or semi-automated testing validation process where the focus is on testing, not really on paperwork, where you really build robust solutions. Because it's like today, it's very onerous, very paper-driven process, which again, from the past, it's really just not able to catch up with the requirements of today.
Yep. Do you think that, I mean, the new thing, I'm not a quality person, right? So, but obviously the new kid on the block is this CSA approach where you've got and instead of your traditional CSV, where
Mm-hmm.
it's more of a risk-based approach. But I mean, I feel like the onus is still there for, especially for tools like, or use cases like maybe we're talking about where you might have, I don't know, maybe it's closer to the product or it still has some sort of indirect relationship to the product. So then you're still kind of back to, well, you still have to document everything. So I don't know if that gets us any further towards this kind of, I don't know, away from paper, I guess, or away
Yeah,
from documenting everything.
I think the spirit of this documents, all of them are make sense. It's not. I wouldn't say that the way how this requirements written, around, whether it's CSV or CSA,
Hmm.
necessarily sort of create the problem. It's more like implementation practices, I
Hmm.
would say, and this is where it becomes hard. You cannot really like be super prescriptive in the document, and in the end, it all goes into, okay, how do you implement it? And I can tell you, since we're building software for a regulated industry, we definitely as well build it in a way to make sure it's compliant with the requirements. And we now rethinking, okay, how do we do it? How do we make sure we follow the spirit of what's required? And again, this is a common sense, right? In software engineering industry, it is something that has been done for a very long time without any regulation, because you just want to have software without bugs, and software that you know will be changing, and you want to automate testing of these changes and make sure that it still works as expected. So if you put a regulation on top of that, it just sort of formalizes it, but the essence of this is the same. You obviously, maybe one thing different with regulation, you need to produce this evidence, and this is what you need to think through. Okay, how I not just make sure that it works well, how I also have evidence to prove it. And this is where lots of things could be automated. And there are now, I know, companies that pop up that actually do that. They uh, um, create this whole ecosystem that brings together this traditional software development, or traditional in the meaning that widely used today, modern software development tools like GitHub, GitLab, Jira, whatever, you name it. They bring it together with and make sure that these regulation requirements are followed around evidence, around producing documentation, and a lot of it could be automated. That's actually where AI could help a lot. And maybe, let's see how it will unfold for pharma and medical devices, but maybe that's where the impact of AI could be felt even earlier than anywhere else, where you just automate this step around validation and around bringing new software in.
Yeah. Do you obviously like for an industry as risk averse as ours, this monitoring of the quality of these predictions is kind of the utmost importance. So do you see, and already there, Elsa's already in headlines. She's hallucinating. FDA, yeah, making up studies. So, like, do you see the use of these off the shelf? I guess you call them off the shelf, but like these LLM platforms that are out there, like ChatGPT or what Claude or any of those things, as kind of a non-starter because you have no insight on, as it could just be making shit up. Like, and yeah, does this factor into the way that you've developed Daikon, I guess?
Yeah, our approach is to be very judicious about using LLMs, and basically try to avoid them if we can. For some tasks, you cannot do this, but for many tasks that are within the many quality processes, like quality investigation process, there are like things like searching for something, right? You don't need the LLM for that, or extracting some information from a quality event. So we
Is
definitely,
that
uh-huh.
is that, like, I need just a bit of education in this area. Is that RAG? Is that the definition of, or is that something a little bit different?
It's different.
Okay.
So basically, what we do, think about, forget about LLMs, but think about a task that the model performs. So it can be classification, or let's say it could be a score that tells you how similar two texts are. So this kind of tasks, if you can bring it into this unambiguous, almost like numeric output format, or some predefined values, or basically something you can measure unambiguously and objectively, this is where you want to be, because you can have metrics around these models, around these tasks, and you can say objectively and scientifically whether the model works well or it doesn't work. And you say, let's say I want a 90% recall, and you can measure it. Obviously, there are some rules around how you do it, in a rigorous way. And it's similar to, let's say, if you deal with linear regression, right? There are like rules, okay, how you say that the model is significant or not. So the same with this ML type of model. So we try to bring as much as we can within this realm. Once you get into text generation task where you generate output, and many outputs could be correct or okay, and some will be wrong or some sort of hallucination, that becomes much more difficult because it's just you still can measure it. There are techniques to do that, but it becomes way, way more expensive. And so you want to definitely isolate these tasks and develop a process around humans reviewing these outputs. And I think what where industry will eventually go is that I think LLMs will be accepted as well, and in even in GMP environment where it's GMP task. But what would need to be done, let's say, human that reviews this LLM, they would need to be trained on this, how do you recognize hallucination, let's say. And I think it's a reasonable approach. So it's not just, we say training for checkbox. This is something that really is needed, because this expectation that just you take any human and they will figure out how to deal with this AI, I think it's a little bit too optimistic, because it requires it requires quite a lot of knowledge, and I would say proclivity as well. I could you can see, I'm sure you have like people in your circle, like some folks just like live day to day with chat GPT, asking them everything, and they're very good and they really get value out of it. And some folks just very skeptical, and they say, look, I'm not telling anything this thing, I don't know where it
Don't
goes,
trust
it
it.
will
Yeah.
hallucinate. The same will be with your team at work. There will be people who will be very good and will just get a good intuition how to understand when the model hallucinates, what kind of environment or what kind of circumstances would it will be prone to hallucination more. And some folks will be okay, I don't know, whatever you told me, I'll just use it and not going to challenge it. So I think it will require some training. And as you get people trained on this, similarly how they trained on, I don't know, Excel, and I sure people will be putting this on their resumes. It's going to be just a job requirement that
Yeah.
how to do
Everyone's
prompt
a prompt
engineering.
engineer. Yeah.
Yeah, it's it's funny, but it's real field. I know there's a lot of sort of people look down at this, but you can get a lot out of the models if you know what model to use and how to prompt it, and how to work with it pretty much.
Do you think some of it stems from, or some of the training should be around? Because I was having this conversation with a friend of mine, Mark Smith, who I was watching one of his talks. One of the misconceptions I think is that these LLMs are actually like there's a reasoning capability behind them, but I think it's important to understand that it's the illusion of reasoning, right? Like there's no thought there. It's that they are predicting words, right?
Correct.
So I feel like that's kind of key to understand.
I
Yeah.
agree with this statement. I don't think it's the key though, because
Hmm.
I think we almost like see them almost like rivals to us, right? And that's why we want to say, look, whatever they do, they it's all fake, and it is fake. We made it, right? It's not that it was born and it's living organism, but there are lots of similarities how we make decision. I'm
Mm-hmm.
reading right now a really great book I recommend. It's called Sources of Power. It's pretty old. I think it was first published in 80s, and it talks about what's called naturalistic decision making. They basically studied people in difficult, stressful situations, how they make decisions. Let's say like firefighters when they putting out fire, and typically how we were taught decisions are made by humans. You come up with a list of options, then you evaluate them, and then you choose the best based on this criteria. In reality, nobody does decisions like that. People really look at the situation, they try to see if they recognize some pattern.
Hmm.
If they did, they say, okay, I will do this. And it's not that they consider like 15 options. They just like go for the first one that seems okay and should do the job. And if they start see some deviations from the pattern, this is when the alert comes up and they start like trying to reassess the situation. And then they may go into evaluate some options and understand what's going on. And if you think about AI, this is essentially how we build it to work, right? It really looks for patterns and it tries to act on these patterns.
Mm-hmm.
So it's definitely fake, but in the sense of um, it's not a human, that's for sure. Uh, um, but it can do the job still. I think if we focus on the goal, these models have amazing capabilities.
Mm-hmm.
And many of them, again, you can measure and they can be very uh, very useful for a very narrow task. There are definitely, this term called jagged frontier, meaning that you have this frontier of capabilities, but it's very uneven. Some things this model can do, and you would think if you sort of follow this arc, right, of capabilities, you should be somewhere here where the same kind of task this model should be able to do as well, just sort of how you would expect from a human. But it just drops. It's unable to do that. This is where the challenge is. This is why it's more complex than software engineering, because there's this randomness that it's hard to control for, and you need to evaluate this model. So that's why it's important. You want to have some kind of evaluation of very, very robust human in the loop process where the humans trained, where the humans know what may go wrong, and you know that they are prepared to act when something goes wrong and catch it.
Do you see that, like those use cases where you can quantify the prediction quality as the ones that will, I don't know, like reach the finish line first in pharma
Yeah.
versus the kind of generalist, like you're just chatting with some generic model that's kind of making some suggestions?
Yeah, I believe so. Overall, I think, and this is the reason why we started the company, is that you really need to integrate it into the workflow, and you need mix of some almost like collected from a Lego of these different AI tools, models, that some of them are very narrow, focused, very specialized, that they need to be fine-tuned for this specific task. And in the end, you can have, let's say, an LLM that summarizes that. But you really need to integrate it into the process. And in the end of the day, it's still building a software. It just, as I said, becomes more complex. So I don't think in the enterprise world, these chatbots, like omnipresent chatbots will do well. They're good for your um, individual productivity, right? Let's say when you want to, um, I don't know, write an email or write a caption for this video, something like that. So that's definitely helpful. I think there is a use case for that, but it's not really about the business process. So for business process, you want to have more controlled, thought through, uh, step by step kind of flow where you know that for each step you're using a tool that you understand how it works, you can evaluate it, you can measure it. So in the end of the day, it will be a combination. But I think the smaller models, smaller transformers, which is, again, it's a transformer, it's the same mechanics, how the model learns and works as these bigger models, but it's just much simpler thing. So you don't really, shoot the mosquito with a bazooka every time. You just
Right.
use like very tailored instrument for that. And by the way, going back to this study of software engineering
Mm,
productivity gains, they found that for some tasks, there is actually negative gain. So some things AI just doesn't help, and it sort of, if you think about it, kind of 2 by 2 matrix, greenfield and brownfield project, like greenfield starting from scratch. So this is where AI tends to be more helpful. If you have already a lot of code, it's more difficult for AI, and partially it's because of this context window, which the more information you put into the model, the more it's prone to hallucination. So you don't
mm.
really want to, feed this huge chunks of data. And this is another reason why I need to break it step by step. And another is complexity. So the more complex task, the more difficult it was for the model. And I think partially it's just because I think naturally you would expect more complex task would require more um, sophistication that model might not have or might not have learned. Plus, you probably don't have that much data on the complex tasks. So what model learned, they learned,
Right.
maybe
From
simpler
this, all the
things that are
simple.
available publicly. Yeah.
Yep. That the token overload
Hmm.
or whatever issue is that, kind of from my own knowledge, is that the number of tokens in a single, or like, let's say I've been chatting with Claude all day long, like,
Hmm.
does the performance degrade over time? Is that what's been studied?
So I don't know the exactly how, let's say, Claude works. They push some context window, push whatever like previous chats into the context as well. Like every time you ask something new, but I'm sure they do a lot of other things to make sure it works. But there are studies, and there's just one recently that came out. It's called I think it's called like context rot, something like this, essentially pointing that as you increase the context window, the quality of the outputs goes down. So it's more difficult for the model really to absorb that much information. And that's, again, that just stems from the way how these transformers learn. They're basically not going too much into technical details, but it's more difficult to process this bigger context, because you really, if you, even for humans is the same, right? If you give you like one sentence or the full page, it's way more difficult to connect the dots and sort of define this, like make this attention mechanism work for the models in a bigger text. So that's why you would see performance going down. So that's why you won't be able to say, like, again, people had an idea, I will just take all my SOPs and throw them into the model and get all the
Give
answers.
me a
It
summary.
will,
Yeah.
yeah, it will get confused. It first, it was never trained on this data, so that it wouldn't have even this tokenizer itself, right? It might be a limiting factor depending how it was uh, uh, the data that it was trained on.
Hmm.
But it haven't seen this data. It's just a huge context window. So that's why you want to think about the task that you try to achieve, break it down into steps, address each step separately with some model, not necessarily LLM, and step by step get it completed.
That training, yeah, I think that brings up an important topic, especially in life sciences, that training data set. And maybe you can bring it closer to home with Daikon. How much of that, like, in making predictions around root cause analysis in the quality situation. How much of that training data set is like a company's own training, a company's own data, and how much is whatever is out there, I guess?
Yeah. So usually all these models, they come with some in some pre-trained state, but we always recommend that you want to use your own data for at least for evaluations, because this is the first step. How do you, and it's more around the process rather than the models and how they build. How do you evaluate each step of the way, and how do you know that that works? And this is partially our value proposition, where we give you this sort of solution that was thought through in this way for any kind of process where you have an event, where you have a cause and an action to prevent this cause in the future. So anything that fits this flow can be analyzed with Daikon AI. When you go into implementation, you need a customer's data to first build this evals, because you want to know, especially in regulated environment, you want to show the evidence that, okay, the model works. Let's say we extract whatever failure mode and we extract the batch number here, we're getting like 95% of the time it correctly. And then once you have this evals, you have the baseline, then you would fine tune these models to bring it to the right state of expectations, whatever metric you choose, whatever the number you choose. And it can vary again. And this is where this risk frameworks come into play, what you mentioned, CSA. So this is where there's a lot of judgment and thinking should be put in place. Okay, how do what should be 80% accurate, or what must be 95 or 98% accurate? This is where humans' judgment is. But I will say this, algorithms primarily getting commoditized. So what these companies have as the asset in this whole game of AI is data, like any company, even outside life sciences, because their data will be their asset. Their data what will make the model that is implemented, which may be open source model that everyone else uses, but because it's fine-tuned on their data, it is unique, and it does some unique stuff that brings value. And there are different ways there, even for LLMs, to do what's called in-context learning. So you mentioned something like RAG, which
Yes.
is a similar idea where you pull the right context and give it to the model to ground it into
Mm.
this right context. So essentially, this is this in-context learning that allows LLM, it's euphemism. It's not really learning. It just like uses this information during inference to make better decisions. So you can do even this, right, without fine tuning. But you want to have this evals, and I think companies, again, that really figure out how to do it in a rigorous way that is sustainable will be way ahead than everyone else. Because if you just sort of go through these endless pilots that impressive, they let's say not give you, they get you like 70% there, but you need 90%. And unless you get this additional 20% uplift, it just not going to make sense, because you would make humans, to review it every single
That's right.
time, and the whole productivity benefit is gone.
How much of
So,
the importance there of that difference in prediction quality lies in the quality of the like data quality of the training data set, I guess? And is
um,
there a challenge there with some of these? Like I think of the companies that I've been a part of, like some of our quality management systems were just free text fields, right? And
mhm.
so it's like, well, the operator could put that in, but it's not necessarily required, so maybe they didn't, or maybe they mistyped something.
Yeah, it's these algorithms, they're robust to these problems with data quality. Let's say if things are not formatted nicely, or they mistyped, or it's sort of a confusing language. So I think in that sense, actually, these models do a pretty good job. The type of data that you also want to have, and I think this is what as well people don't realize, is one new data element that is being added right now that you need to keep in your mind is annotated data. I haven't seen anyone like having any concerted effort to preserve it and to store it, because it's important. Let's say I can give you some examples. Let's say someone did analysis, right? Some quarterly trending um, for deviations. So this is your annotated data. Someone said this 5 deviations fall into this group. Human reviewed it and human confirmed it. And this thing, nobody even looks at it as an asset. It like sits somewhere in an Excel file in someone's shared drive. Nobody cares about it. But this is like, moreover, from these 5 records, you can, if you think about Cartesian product between them, so it's like 5 times 5, right? 25 pairs of similar deviations. So this is another annotated data that you can derive. And you can collect tons of this very valuable stuff across your organization if you put a goal to do this. And this is what lots of companies should be doing, because this is what is important. This type of data is very valuable. And this is something that if they have it, then they can, bring a service provider, do it themselves, or bring us, and we'll help them to make a process out of it. But this is the secret sauce that nobody else will have for their use case.
Is that a feature that you are building into Daikon, or is that something that you see like it's more of a business process where people should be going back into the source system, maybe it's TrackWise or whatever, and saying like this was the actual whatever root cause or something to add to the
What
deviation?
we're doing, we're the way how we design our solution to facilitate taking this data in, and we have sort of standardized way how you describe this annotated data. So we have standard tables for different tasks
Hmm.
and annotated data for these tasks.
Hmm.
Let's say if you extract something, or for this like similarity search or classification problem, so it's very easy to upload it into Daikon AI, and then it will sort of flow through the process. You don't need to think about it, but definitely getting this data that's going to be on the customer. One another feature that we have that I think as well many companies will come to realize that they need something like that is annotation within the solution itself. So every time you see any kind of AI prediction, any kind of search result, we have buttons for feedback loop, and you see it in ChatGPT as well, right? You have thumbs up, thumbs down. It's a little bit more convoluted there, given it's text, so I'm not sure how
Objective.
exactly they
Yeah.
use it. But in our case, you can, through this annotation, as you use the tool, you can do 2 things. This is your way to collect annotated data and say, okay, my model works because all over the last, let's say, 6 months, I got this feedback from the users, and my inaccuracy rate is, below X. So you can do this. Plus, you can reuse this data to uptrain your models as things keep developing. So you want to have this loop of human feedback, uh, even when your models got to very good state, you still want this feedback loop where you can evaluate, okay, are things working well? And this is, again, this is another complexity that you add, right? Because you don't do it with your typical software. You don't need to think about, okay, these parts of the software, are they still working? And this is something similar. If you think about it, it's almost similar. Like if you take biologics process, right? This you have to have all this process monitoring to see if your cells are grown in the right
Mm-hmm.
way, and you sometimes you like have a difficulty understanding what might have gone wrong. So it's kind of similar in the level of complexity and monitoring it requires.
And I feel like it gets to that point, like where you were kind of leading with this annotated data, even with process monitoring, it's the same thing, or deviation investigation. It's like you've got this one person who's been at the company for 35 years, and he's seen every type of deviation. So like you got to invite him to the meeting in order to, and he says, "Oh, I've seen that before," him or her, and that's the type of data knowledge that you kind of have to bake back into the whole loop, because
Exactly.
then everybody can become the expert.
Yeah.
I think that's the
I,
dream.
I won't be surprised if in the future companies will mandate that every single meeting within a company is recorded.
Mm.
Almost like every single interaction, and that goes into these models to train to do exactly that, so that you can, I know it sounds like a little bit like orderly, like 1984 type
Right.
of scenario, but who thought, like, I don't know, 20, 30 years ago we would be putting all kind of pictures online on Facebook and things like that.
That's right.
So I think we'll get there where we just basically, companies demand the ownership of all the data, literally every single piece of it that is being generated from 9 to 6 while you're working for this company. And again, I made it sound a little bit too dramatic. There are definitely ways how to make it sensible, and I'm sure there will be concerns about human privacy and things like that. And but right now, if you think about it, right, if you just take investigations, let's say, capturing every single meeting actually would make sense on this investigation, and then attaching it to your QMS and using for these models. And this is something that we have on the roadmap that we want to as well, to allow people to add this additional meeting transcripts that could feed into the analysis, because it is very useful use case. This is where LLMs actually could be very helpful to just to help to summarize, okay, this is sort of your timeline of things that happen.
Well, it's been an absolute pleasure, Nikolai. I know we're probably gonna wrap things up, but yeah, I'm interested to see how the Daikon platform evolves, and we'll have to connect again soon too, because this, like, things are
Yeah,
constantly changing with this
it's a very
landscape.
interesting field. One encouraging thing is that there is a lot of appetite from pharma and life sciences overall, which is good, which I think, you definitely need this. This is the first thing that is required. And there's a lot of work to be done as well
Yes.
to adopt all that.